Alright, last section for week 1. Section 1.3, we're going to continue talking about the letter F exercise. So you should have found out how many F's there are in this little letter. When I do this in class of 20 people, I usually find that some people say 10, some people say 12, 15, 17 letters. Everybody, or a lot of people have different answers. And chances are you're someplace in there between 10 and 23. By the way, there's 23 letter F's in there. Yes, you can repeat reading it and counting it. There's 23 F's. The point of this exercise is that almost nobody gets it right. And there is a lot of variation in how many F's people find. Even though they all read the same paragraph and they're all fresh in their mind, they all want to do a good job. So this little exercise illustrates that inspection is not a good method to control quality, because people will miss defective items. So if you want to make sure nothing bad gets to the customer, you cannot rely on inspection. You have to start earlier in controlling quality. You have to start on the process. Once the product is made and you try to inspect quality into it, that doesn't work. You have to focus on the process and analyze the process to prevent bad things from happening. Alright, we are still talking about the evolution of modern quality. Total quality management was an approach that was developed after statistical process control. It's a management approach that places emphasis on continuous process and system improvement as a means of achieving customer satisfaction to ensure long-term company success. So instead of just making sure you have standards in place and you can analyze your processes, you continuously trying to improve your processes and make them better. And you do that using statistical process control and input and expertise from all employees. Take a look at figure 1.14 in your book on page 13. Next higher step in the evolution of modern quality is continuous improvement. It focuses on improving processes in order to enable companies to give customers what they want the first time, every time. So now we are focused on customer, and we want them highly satisfied. We want to produce or give them the services that they want the first time correct and every time correct. And it's very, very customer focused, and there is an ongoing commitment to improvement. And then we have the Six Sigma methodology as a very high step in the evolution of the modern quality. It is a quality methodology that focuses on achieving a near perfect process by reducing variation for every product, process or transaction in a company. That near perfect process could be translated to 3.4 defects per million opportunities. So you have very, very, very few defects. And for those of you familiar in manufacturing, it also translates into using only half the allowable tolerances or half the spec. If you use only half the spec in your process, in your standard, you will have a Six Sigma process. The goal is eliminating all defects, and in a Six Sigma company you typically use the improvement methodology that's called the DMAIC model to work through projects to improve your processes. And DMAIC stands for Define, Measure, Analyze, Improve, Control. In each phase you go through certain steps and milestones that will help you in the end achieve that near perfect process. We have a class that's strictly dedicated to Six Sigma. So if you want to, you can sign up for that next semester. It's the IET 440. We also allow certification in Six Sigma here at Missouri Southern. If you go to any of the job boards online these days that have to do with management or manufacturing or even healthcare, most industries out there are familiar with Six Sigma anymore, and the job ads will say Six Sigma Green Belt or Six Sigma Black Belt desired, or sometimes even required. So it's a good thing to have on your resume. If you are interested in Six Sigma certification, just contact me and we'll talk about it. Now, the book also talks about quality standards that are in place, have been in place for a long time. For example, the ISO 9000 standard, which was developed by the International Organization for Standardization. Standards provide a baseline against which an organization's quality system can be judged, which makes it really helpful in this global economy to compete or do business with other companies, because a German company can do business with an American company, and they can, for example, specify we want a material that has a certain tensile strength, and if the company is ISO certified and follows all the standards, they know that number one, they probably they will use a certain standard to test the material for tensile strengths, and that standard will be the same across the world. And number two, it will guarantee that company that it, for example, guarantees the German company that the American company has quality systems in place, standards in place, and it will follow them. So it guarantees a certain level of quality. Now, there is 8 key principles that are integrated in the ISO 9000 standards. So a company would have written standards for the following 8 principles, and they will have been audited to make sure they follow those principles. First one is customer focused. Second one is leadership. Then involvement of people, process approach, systems approach to management, continuous improvement, factual approach to decision making, and mutually beneficial supplier relationship. Why do you think companies want to improve? Why do you think world-class companies evolve in their quality philosophies? Why don't they just stay the same? Why weren't they stuck in inspection, which some companies are still stuck in inspection? Well, these days you compete not just with the company in the next county or state, you compete with the whole world. And as soon as a competitor evolves in their quality philosophies and gives the customer a better product at the same price, or maybe even a cheaper price, you're going to be run out of business unless you do the same thing. So you will have to improve continuously just to be able to stay competitive. Let's talk a little bit about cost of quality. Most companies keep track of their cost of quality, which by definition, according to Crosby, the cost of quality is the cost of waste or the cost of non-conformance. It's basically the money you waste by not doing it right the first time. Let's take a look at the cost of quality of air travel. On average, between 2001 and 2008, 99.6% of passengers arrived at the same airport as their bags. Well, that sounds pretty high, doesn't it? Now, it may be surprising to you because for those of you who travel by air, if you're anything like me, there were plenty of times my bags didn't arrive with me at an airport. But there's so many people traveling that if you put it in statistics, it's still 99.62% of passengers will arrive with their bags at the same time. So it does sound pretty good, doesn't it? But this quality standard of 99.62% is not all that great. It causes passenger inconvenience, loss of customer goodwill, cost of tracking the bags, locating and rerouting them, cost of delivering luggage to owners, cost of reimbursing customers for incidental expenses while they wait for bags, cost of handling extra paperwork to settle lost claims. So there's a lot of cost involved for airlines for having a greater than 99% success rate. Actually, the estimated cost for a single airline reuniting just 100 bags with their owners per day at a hub airport such as Atlanta or New York is more than $2 million a day. a year, 2 million a year. The source for that is at the bottom there. Now, if you look at that, greater than 99% arrival where bags and customers arrive at the same hub at the same time isn't all that great, because it still costs the company, that's just one company, just reuniting 100 bags costs them more than $2 million a year. That's a lot of money that could be saved if they do it right the first time all the time. Here's some manufacturing examples of quality cost. Redesigning a faulty component that never worked right. Reworking a shock absorber after it was completely manufactured. Whenever you have to rework something, it's extra time, extra money, extra material, so it's cost of quality. Retesting a computer chip that was tested incorrectly. Rebuilding a tool that was not built to specification, all that costs money. Repurchasing because of non-conforming materials. Responding to any customer complaint. Wasn't done the first time, so it costs money. Refiguring a customer's bill when an error was found. Expediting late shipments by purchasing a more expensive means of transportation. Providing on-site assistance to customer experiencing problems in the field. Providing credits and allowances, all that costs money. There is 5 different types of quality costs that your book talks about. There's external failure cost, internal failure cost, appraisal cost, prevention cost, and intangible costs. Let's try to make sense out of all of those. Internal failure cost is the cost associated with product non-conformities or service failures found before the product is shipped or the service is provided to the customer. So, in other words, you get ready to provide a service to the customer and you figure out, whoops, something is wrong. Or you have manufactured a product and then you figure out before it's shipped that something is wrong, so you rework it or you scrap it. That's internal failure cost. External failure cost is any cost associated with product or service after it reached the customer. So you made a product, you shipped it to the customer, and then the customer says, oh, something's wrong with this. For example, this toaster doesn't work. That's external failure cost. Or you ordered a meal, you get the meal, you start eating it, and then you realize, whoops, it's completely cold. So the service has been performed, it got to the customer, and then the customer complains. Appraisal cost is the cost associated with measuring, evaluating, auditing products or services to make sure that they conform to specifications. We have some examples come up later. The cost of prevention, that's any money you spend to enable you to do it right the first time. For example, training people. They are those costs that occur when a company is performing activities designed to prevent poor quality in products and services. And then you have the intangible costs. That's kind of hard to measure. It's all those hidden costs associated with providing a non-conforming product or service to a customer. They largely involve a company's image. Maybe you buy a washing machine from a certain company or a computer from a certain company and you keep having trouble with it. You probably tell all your friends, don't buy from such and such company again. It damages the company image. That's the intangible cost. I give you some examples here for each type of cost of quality. So cost of failure external, that's when it reached the customer, our warranty returns, technical support, lost business, returning product, liability costs, corrective actions, and so on and so forth. Some examples for internal failure include scrap, rework, any type of repair, material failure reviews. Now keep in mind, it hasn't gone to the customer yet, but it's after the product or service has been provided. But it hasn't gotten to the customer yet. Engineering changes, corrective actions, rewriting a proposal, stocking extra parts, retesting. Alright, cost of appraisal, audits, which means you have somebody go and check, for example, if procedures are followed. Incoming inspection, This refers to companies who don't really trust their suppliers, so they inspect all the incoming material. Costs money. In-process inspection. Sometimes it takes 10 steps to produce a product. In-process inspection means that maybe after each step the product is inspected. The sub-assembly, for example, is inspected. Test and inspection equipment costs money. Product evaluations. And then the cost for prevention, any type of planning, like quality planning, is prevention. Quality program administration, for example, if you have an ISO system, administering cost money, or if you have Six Sigma company, administering that will cost money. A lot of companies have supplier rating systems in place to rate their suppliers. Maybe you have some star suppliers that do everything right all the time, that have quality systems in place. They may get an A rating. You may have some suppliers where periodically something is wrong. They may have a C rating. Any research that goes into customer requirements is chucked up under cost of prevention. Any type of product design review or development review is under the cost of prevention. Spec reviews, any type of training, any type of preventative maintenance, all under cost prevention. Which cost do you think is most devastating for a business? If you said external, you're right. The external cost is the most devastating to a business because it has reached the customer. Not only is it more expensive of a quality cost by the time it reached the customer, you also have to worry about that intangible cost, that image problem that you caused. On this little scan, you can see the increase in quality costs as a faulty product reaches the customer. On the x-axis, it describes the time when the failure is found. So at the very left, ideally you have prevention costs in place, and then the failure cost that's described on the y-axis will be very small. Next phase, the failures found during the design phase, you can see the cost to a company goes up a little bit. Then the failures found at onset of manufacture or service provision, the failure cost goes up there. Onset of manufacture means you have already invested in tooling, for example. But it's still better to find the failure there than at final inspection, when you have maybe moved the product through the 10 steps it takes to make it. If the failure is found by shipping or created by shipping, it's still more expensive. If it's found at installation, it's still more expensive, and so on and so forth. So the sooner you find a failure, the better. This is a little figure that shows the increasing cost associated with a faulty lawnmower. So the cost is smallest if you notice during the design phase that you have a flaw in your systems or in your product. The cost to a company goes up a little bit if you find the failure at the start of production. If you find it during assembly or testing, it will go up even more, and of course it's most expensive if you find a design flaw when the customer has the lawnmower, when it went all the way to the customer. Those things happen when you know something happened like that, when you hear product recalls on a lawnmower or a car or a baby product. You know something went wrong in the design of the product, and that's tremendously expensive to a company. This table describes the cost of quality in relationship to defects that you make. The first column has the sigma level of a typical of a company. The second column, the defects per million opportunities associated with the sigma level, and then the last column has the cost of quality associated with that. That table was put out by Mikel and Richard Schroeder. They looked at a lot of companies, at their sigma levels, the associated defects, and how much money they spend on cost of quality. They said the average United States company operates at a 4 sigma level, which translates into about 6,210 defects per million opportunities. That means that a company like that spends 15 to 25% of their sales dollars on cost of quality related items. That means almost a quarter or up to a quarter of the money they bring in. That's not the profits, that's just the sales dollars. Quarter of the sales dollars they bring in is wasted on cost of quality related items. Take a look at the amount of improvement companies can make, the amount of money companies can save by reducing that cost of quality number. A Six Sigma company spends less than 1% of their sales dollars on cost of quality related items. That's why so many companies have started to become Six Sigma companies and followed the Six Sigma philosophies. It's dollars and cents. This figure kind of shows you how the overall cost of quality, which is described in the size of the bars, how tall the overall bars are, can be reduced if you implement quality improvement efforts. On the left bar you can see that the total of cost of quality is relatively high compared to the right one. You have a large chunk of failure cost, a pretty good sized chunk of inspection, and a very small chunk for prevention. On the right column, company spends more money on prevention, which translates into having to spend less money on inspection and having a lot less money to do with failure cost. And then you can kind of continue that thought. If you would spend a little more on prevention, you would decrease the inspection cost and failure cost even more.